I might get started. Okay, so welcome everyone to today's masterclass. My name is Tim. I work at the Informatics Hub, and today I'm going to take you through internet security. So it's a little bit of information about the Sydney Informatics Hub. If you don't know us already, we are a core research facility at the University of Sydney. We help researchers use high-performance computing, analyze data, and get the most out of their research. So we can help researchers access high-performance computing, modeling, visualization of their data. We provide consulting for statistics for students and researchers, both server design and modeling. And we also provide data science, analytics, help with developing software, and we can also help with grant application support. In addition to that, we also run training sessions and events like once a month we have Hacky Hour, where researchers, student staff at the university can gather and we online, and we can talk about their research, what the things they're getting stuck on, and help solve whatever problems barriers to you. And we have that once a month, and the next one, which will probably be the last one for the year, is on 15th of November next, in a few weeks' time. And then we also have training sessions on, for example, using machine learning, and well, masterclasses like this one once a month. And so the slides, which will go online, have a link to our training calendar, but you can also find it us through the university website. So it's just a bit of introduction to our group at Sydney. But now I'll get started with the masterclass. So today, going to talk about internet security, and of course, it kind of goes without saying, these days, we all know we use the internet for many things, from shopping, banking, accessing government services, health services, social media, of course. And with all these things that we can now do, I mean, it's very convenient, but we have put a lot of data out there that, potentially, right, could be stolen. And we also don't want to have, our ID stolen, people being able to access our bank accounts and, block us blind. So we need to be able to secure our data somehow. And so that's what we're going to talk about most today. Firstly, how does internet security work and sometimes fail? And I'm going to be focusing mostly on password security. So I'll go into a bit of the mechanics of how passwords work and how they keep us secure and how they can be broken. And then some things about how we can minimize our risk. How do the breaches happen, and how can we try and avoid that wherever possible? Okay, so let's get stuck into how passwords work. So if we got a user, this blue person here, by the name of user 1, and they want to use a website, whatever it is, banking, social media, whatever, they want to sign up to the website and use it. They sign up with a username, they use their own name, user 1, and then they use a password, and they can use the password, which is a terrible password. I mean, I think we all know that, but let's just see where this goes. And so the website's going to store that password in a database, and in the database there will be a table with the username and the password stored. Now, this is a poorly run website, which is not very, very secure, and they've just saved the password in plain text as the word password. Not great, because what happens if, when the person wants to log into the website, then they enter their details, the website checks the database, confirms that the password matches what they've saved, and that's all good, so they can log in. But what happens if someone nefarious gets access to a database, or even just they happen to have access to the database because they, work at the company the website belongs to, and then they can just read the password file and find out what your credentials are. And then they can go to the website, log in, view details and whatever. So obviously that's bad. We don't want that to happen. So how should you store passwords safely? So any good website should never be storing passwords in plain text, because then anyone has access to the password. Now that should never happen, but it does. Not so much anymore, but historically there have been several data breaches. For example, Sony from about 12 years ago had a big data breach. They had many user names and passwords stolen, and it was found that the passwords were actually saved in plain text. So all those passwords which were released on the internet were free to use for anyone to access. And you may have known when websites have been doing this, because sometimes when you request that you have, if you got your password, you say, I've got my password and want to get access to your account, they might email you what your original password was, which they shouldn't know. We'll get to why they shouldn't know in a moment. But if they've done that, then they're probably saving their passwords in plain text. There's a link here to a website. It's got about a decade of offenders where different websites, mostly these days it's a random blog or whatever, where they're not putting that much effort into the security, where it may still happen. But hopefully by now, any important websites, for example, banks or healthcare providers, shouldn't be saving passwords in plain text. So what should happen is the password should be encrypted by the website. So for that, they use something called a hash function, which takes any input and produces a hash. Right? It's an output of a certain fixed length, and it's an encrypted version of the password. For example, here are two examples of words cat and password encrypted with a particular hash function called SHA-1. And you can see that they're both the same length, about 40 characters long. These are actually numbers. They are a hexadecimal number. So the letters represent digits beyond the digit 9. So you have A through F or 10 through 15. And so this is a encrypted way of storing these words. What makes a good hash function for cryptography? One, it needs to be deterministic. So if you put in the same word, you'll get the same hash again and again, because we want to be able to verify that the password that you put in later matches the password you created at the beginning. Correlation resistant. That means if you put in a password that's very slightly different, it creates a completely different hash. For example, if you put in cat with a capital C instead of a small c, you can see that this hash is completely different to the small c cat. Right, so that means it's hard to work out what the original password was from its hash. Right, so another way of saying it is it's pre-image resistant. You can't get backwards from the hash to the input. It's basically a one-way function. To be able to go backwards, it requires solving a very difficult mathematical problem, which is currently beyond the ability of computers. Collision resistant is another thing that's very important. So you can't find two inputs that use the same hash, right? Because if you could generate whatever input and mold it to form whatever output, you don't need to know the password. You just need to be able to create whatever hash you want to. So collision resistant is also an important thing for a hash function. And finally, it needs to be fast enough that it's convenient. We want to be able to use these functions to quickly enough convert your password into a hash. but we don't want it to be too fast because, as we will see, being able to generate hashes is a way to brute force our way into a system. So now if we've updated our website, our user's still using a table password, but now the website hashes the password into that 40 character long random sort of numbers, and it's saved now on in the database with a in the hash form. So now when the user logs in, the website hashes what they entered as a password, confirms that it matches the database, and everything's great. Right, but now if the user forgets their password and doesn't and requests it to be reset or sent to them, the website can no longer send them the password because they don't know the password, they know the hash of the password. And also, if someone else comes along, right, they now know the hash, but they don't know what password created it. So they can't type in what the password was for the website to hash it to check that it's valid. Right. But can someone who wants to hack in guess what the password is? And in this case, password is not hard to guess. Right, so, and also if it's a very common password, as password for some reason is, many users may have the same password, and if it's stored insecurely, then the hacker could see that, okay, this password is common, many people have it. It obviously is a fairly easy one to guess. Right, so how could they, guess what a password is? There's two kind of broad directions that you can try and attack and crack a password. One is the brute force attack, so it's just kind of checking every single combination, AAAB, whatever, through until you find the right password combination. And the other is a dictionary attack, where you have a list of passwords that you want to try. Now, typically you'd use passwords that have been used before. Right? So from previous data breaches where, like the Sony one, where everyone's passwords were revealed, check all those passwords. People use passwords all the time. You can also try from this common substitution. So changing an A for an at, or a S for a dollar sign, or a O for a zero. And another way to do a dictionary attack is to pre-compute different hashes for every single combination, and then instead of checking all those words and then hashing them, you can look up all the hashes that you've pre-computed and find the corresponding password. So that kind of it's quicker in one way, but it requires a lot of storage of all the pre-computed hash table. Right. So, how long does it take to brute force a password? So this is a table which shows how long your password is, number of characters, versus how complex it is. So just using numbers or lowercase letters or combination, and also including symbols. How long it'll take a decently modern computer. If you've got enough computer resources, how long would it take to cycle through all the different options and work out the hashes and see if it matches. So obviously, if you have a short password, that happens much more quickly. And the longer your password and the more complex the mix of symbols it is, the better. Right. So to a point where it's particularly long, it will take longer than the universe has been around for someone to brute force it through. But like many passwords that people use are 8 characters long, and you can see that it doesn't take that long really to brute force an 8 character long password if you've got sufficient computer resources to do so. And things have changed over time because as computers get better and better, the ability to brute force has got easier. So the group that made this table Hive systems have done it a few years now, from 2020 to 2023. And you can see, as computers have got faster, what used to be a relatively safe password no longer is. So even if you know, if your password is good now, it might not be next year. This is also for particular hashing function. So that way we went from password to a mix of characters. There's different versions of doing that, and some of them are more secure than others. And in particular, for example, this table's for a hashing function called MD5. MD5 is a rather old hashing function that is fairly weak. There are more modern versions that are more secure. So, for example, bcrypt is another one. And you can see here, as long as the password is encrypted this way, it's much, it would take 100 years for an 8-character password using today's current computers to be able to brute force it. I mean, but again, next year would be won't take as long once the computers have been improved. But you don't have control over what website uses what encryption. Right? But bcrypt is more state of the art than MD5, but you can't necessarily guarantee that the website you're using is using the most state of the art encryption. Right. So the important thing to do is to make sure that your passwords are as strong as possible, even for a weaker encryption. So the other type of tech I mentioned was dictionary attacks. And yes, many websites have had their account data breached. So you can find online hundreds of millions of breached passwords that have been used. And then someone wants to hack into a system, they can use that, search through, and see if any of those passwords work. There's a great website for working out whether your data has been involved in one of these data breaches. It's called Have I Been Pwned? And if you've got the website and you can type in your email, and this is what you get for one of my an email I used to use 20 years ago, and it's been involved in a few data breaches. Not that many, which is good, but that's involved in any is bad. And the website will tell you which data breach that it was involved in, what data got compromised. So in this case, email addresses and passwords. So obviously, I don't want to use any passwords that I was using back then. The website also has a list of passwords that have been breached, so you can check whether your password is secure or not. This is what happens if you type in password as the password in here, and yes, it exists almost 10 million times in the database. It's been breached so many times. Password is one of the most common passwords that ever gets used. 1, 2, 3, 4, 5, 6 is another really common password. QWERTY, just like the top letters of the keyboard. All of these are very common passwords. They've been used before. They're not at all secure. They can be breached instantly. So don't use them. Right. How do you choose a good password? There's this comic from XKCD, which is an online comic, which points out that we've got used to being trained that we should choose a mix of characters, maybe based on a non-common word. There are common substitutes that people make to make it more memorable. But it's actually difficult to exactly remember what you did for that password. And also, you got to remember this you shouldn't be using the same password for multiple websites, because it gets breached someplace. It's susceptible at another. So they make the suggestion that a passphrase can be more appropriate, even if you only have 4 words, because there's so many words to choose from, it can be more secure. And actually still easy to remember. Yeah. I just noticed Chell in the chat asking how to know that have I been pawned, company is not collecting my password when I check. Yeah. And Hamish is correct that you enter your email, not your password. But they do also have a list of passwords that you can type in your password here. Yes, and that is a question. Could this be a malicious website that is harvesting passwords to check on you? And yeah, perhaps we don't know that. So that's another good point, is that you don't trust anyone online. The website is run by an Australian internet security consultant. Name escapes me. Lives on the Gold Coast. So it's a well-known allegedly repeal website, but maybe this is not. Maybe you go to maybe someone spoofs that website, and you think you're going to have a right website, but it's not. Yeah, so probably don't go entering random passwords into random websites. People in the chat have answered that so you never actually send the full password. It just tells, okay, which is great to know. Thanks, Marius, for answering that in the chat. Right, so the passphrase can be secure and easy to remember. But having said that, for example, correct horse battery staple is no longer a good password because it appeared in this comic 10 years ago. And so people have used that password and it's been hacked and it's no longer safe. Is there anything else I wanted to mention here? Yeah, so ideally a long round collection of letters, numbers, upper lowercase symbols would be what a good password is, but it's really hard to remember. Except what you probably should be doing is not trying to remember a really long collection of random characters for every single website you go to, but using a password manager. So a password manager stores your passwords, so you don't have to remember all of them, which means you can make them as unique and as strong as possible. And then this password manager itself gets secured by a master password that you have, that you should make as strong and memorable as possible for you. So a passphrase might be appropriate here. And so there's a few password managers out there on the market. Some of them you have to pay to use. Some of them are open source and free. So there's a variety out there. Bitwarden is one that I'd recommend, and 1Password. There are a number of others. I can shop around, and it might seem like this is just pushing the problem further along. Like, what happens if your password manager gets hacked? So there's a couple of arguments to say why this is still better than having a random collection of reused passwords that aren't that secure. For one, you don't have a lot of random passwords that aren't that secure. You can, you just use a very strong password instead of lots of weak ones. And also these services, do also encrypt the passwords that get used. And so it's a bit like keeping all your credit cards in your wallet if people still use wallets. And having somewhere where you can watch, as opposed to kind of having this it all out there, but without much control. So I will now talk about some data breaches that have occurred previously, and how they happened, and what we can learn from them. So in towards the end of last year, there were two very large data breaches that were have happened in Australia that caught a lot of attention, because many millions of Australians had their data accessed. So one of them was Medibank, the private health insurer. So how that happened was that the system was initially accessed with a username and password that was stolen. I haven't seen it reported exactly how it was stolen, but it's quite possible, given how it's happened before, that it could have happened by a phishing scheme. So, for example, I'm sure we've all got emails where it looks very suspicious. They want you to click on a link and enter your details. Obviously, don't do that. But some phishing schemes can get very targeted and very sophisticated, that it can be not at all clear exactly what is and what isn't a reputable email. So the hacker, having got this username and password, which was from a third-party IT service provider that Medibank used those credentials to access the network, and unfortunately the network had a misconfigured firewall, which should have prevented accessing certain parts of the system that it did. And then once it had got onto this system, the hacker was able to obtain further usernames and passwords and gain access to Medibank systems, and download data and extricate it. There's a link there to an article that kind of explains more about what happened. And this is actually quite similar to a data breach that happened at a university at ANU in 2018. ANU's released a report kind of going through exactly what happened. It started with a spear phishing attempt. So this is a very targeted and particular employees at ANU to try and get their credentials, because the hacker was aware that these people had access to certain systems. Right? They weren't going for a low-level target. They were going for people with access to sensitive information. In conjunction with being able to get some of these credentials, there were also computer systems at ANU at the time which were not sufficiently updated, which made them vulnerable to being used to gain access to systems that they should not have had access to. And so this schematic kind of shows some of the things that happened. Some spear phishing on particular targets. Several computers across the system being infiltrated. In particular, they gained access to the mail system, which allowed the hacker to view the emails and schedules of the people that they wanted to target to get more credentials, and send very specific emails that seemed relatively benign, like I'm contacting you about this particular research program, and there's a link that for to download a malicious document that's going to install a keylogger or something to get the credentials of the target. They were able to access administration records and export it from the ANU system. And this went on for about 2 months. They were at various times that they lost access to parts of the system where things had been updated, or the ANU security, cybersecurity had detected something was going on, but from November through much of December, this hacker was able to exist on the ANU system and access a lot of data. So in response to that, there's a few lessons we can learn. Like for one, at this time, ANU was only using, access to systems, using username and password. Since they and UCID and other universities have rolled out two-factor identification. So not only do you need to know the password, but then we've got a app on our phones where that sends a notification to confirm that it is us who's trying to log on, and we have to confirm that it is us. And so there's two things that are confirming that we should have access to the system. Not only do we know the password, but also we have possession of an item known to belong to us, namely our phones. And so that's one way that this could be made more secure. And the other thing is to make sure your systems are updated and as safe as possible by keep them updated, not having access to parts of the system where they shouldn't have access to. So that's the ANU data breach sounds a lot like what happened at Medibank in terms of stolen credentials and access to the systems that we shouldn't have got access to. Then was the Optus breach, which also happened about the same time last year as the Medibank one. And there's conflicting claims in the media about how this happened. It seems to be consensus by many internet security professionals that what happened was that an API, an application programming interface, this is how different computer programs talk to each other and exchange information. A endpoint of an API, which was a website, was left unprotected and publicly exposed. So without needing a username or password at all, anyone who found the website could have asked the API for data on whatever customer ID was asked for. So there's a number of security breaches, if that is indeed what happened, but shouldn't have happened. The API shouldn't have been left public and exposed and unprotected. Like it appears this was set up for development for testing the system, in which case it should never have had access to sensitive customer data in the first place for that API. There was also a vulnerability in how customer IDs were saved. In that, the user IDs in the database were just sequential numbers, which meant it was quite easy for the person who managed to find this vulnerability to just automate a script to go through all the ID numbers in order and just extract the data. Whereas if they had been a bit smarter about how they save the customer ID, then you couldn't just cycle through a number of characters because the ID wouldn't be sequential. It'd itself be a hash of with random characters. Now, Optus itself has said in the media that it was a more sophisticated attack than what has been alleged. What actually happened? It's I don't believe we still know yet. But if it was such a kind of a simple, error in just leaving an API left unprotected like that, it wouldn't be the first time. And actually, there was a data breach at the University of Sydney about 12 years ago, where student records were able to be accessed through a website. People noticed that if they accessed their student records, the website address had their student number just in plain text in the address. And if you type in somebody else's student number, the website would return to you another student's data. Right, that was a terrible error in the way that the website was designed. But design websites is difficult. Still shouldn't be. That still shouldn't happen. And when they got exposed, obviously they fixed it, and that should now no longer happen. But it goes to show that there are many moving parts to making sure websites and computer systems are secure, that even if you do everything you right about having a secure password and not reusing passwords, right, the way systems are designed can still leave open our data to be affected, which is not great news, right? So I noticed a question in the chat if it was safe to sign up now for, say, Medibank. I guess that there's an irony in that once a company has been affected by such a terrible data breach, they are more likely now to be to fix the game and be more secure down the track. Right, for example, ANU and other universities, like you said, learnt from its data breach by rolling out two-factor identification to all staff, and making sure systems were more regularly updated. So yeah, at some point after a breach, maybe that's the safest time for that particular website. But yeah, so a few more tips. So yeah, use a password manager. So you can have passwords that are secure as possible, and don't use the same password for multiple websites. So if one does get breached, it's only that website that's affected. Somebody can't then use those credentials to try and access your bank or your MyGov website. Right. Don't share information you don't need to, right? Which is easy to say, but I mean, in the case of your healthcare provider, like if it's Medibank or I mean, we all need in modern day access to telecommunications. So I mean, a third of people use Optus or so. They need your information to be able to provide you with a service. But yeah, if there's any time where you cannot share information, probably don't. Right. Particularly after the Optus breach, and Medicare happening about the same time, there's now movement from the government to tighten up laws around how businesses and institutions store and secure data that they have, and that they shouldn't hold on to data longer than they need to. So there's movement in a regulation sense on that, which is a good thing to come out from those breaches. Be alert to cyber threats such as phishing, right, which is what seems to have caused the Medibank and the ANU data breaches. Use multi-factor authentication wherever you can. So the university requires us to do it. The MyGov website also uses multi-factor identification or authentication. But there are some websites which make it optional. If it's optional, if you're able to do it, you should. And finally, keep all devices you have updated, because there are security vulnerabilities that are discovered quite regularly, and when these once they get found, they get fixed. But if you're not keeping your device updated, then you're leaving yourself vulnerable to that. And with that, I will finish up. So there's a QR code here for providing feedback on how you found today's masterclass. Follow us on all the social media channels. This will be uploaded to YouTube at some point, and there's other masterclasses that we've had are also on YouTube. And come along to Hacky Hour if you have any questions about research, getting stuck on statistics. Come along November 15th at 3 o'clock on a Wednesday. And that's it. Thank you very much. Do we have any questions? I guess there's quite a few that happened in the chat while I was speaking. Yes. What would be the new recommendation for password length? As long as possible, as long as the website allows. I'd probably go for 16 characters, just as if possible. If you're using a password manager, you can use a password manager to generate a password, which is a random string of characters, and then that can be as long as possible, and then you don't need to remember all those characters, because remembering 16 random characters is too much. That's not how our memory works. So yeah, I'd go for about 16 characters roughly. But yeah, and then of course you still need your master password to access your password manager. In which case, if you're using a passphrase, like that example, correct horse, staple, battery, whatever it was, don't use that one. Make up your own. Use weird words that are not likely to be the first one's guessed. But make sure it's memorable. Then yeah, if you're using 4 words, then that's already going to be up around 16, 20 characters or whatever. Were there any other questions that I missed? So part of the solution to kind of how we make passwords safer is that a well-designed website probably shouldn't allow you to enter a password, select a password that has previously been breached. Right? A well-designed website, down the track, if they don't already, should be checking against that list on Have I Been Pwned to see if your password that you're choosing is it is already known and out there on the web. Okay. Any other questions?
Thanks, Tim.
No worries. Okay, great.
Yeah, mate.
Thanks a lot. Okay.